This is Mastering Mathematics with your teacher, Karen Weston.
Hello, welcome again to another in the series, Mastering Mathematics. We sent you home last night and you had some work to do. But we have to tell you that this is a program sponsored by the Ministry of Education using its ABU unit, Center for Mathematics Research and Worry Education, and ABS Television. Again, this is an input from the government of Antigua Barbuda in making certain that we do expand our education plan and what we can offer our students in terms of showing you that education does not just take place in a classroom but happens outside the walls of the school. And we are going to make certain that the technology afforded to us, and oh yes, I have to compliment the Minister of Telecommunications, the Right Honorable Eddie Mansour, who kept his promise in saying that tablet is going to come very soon. They're working on it. Yes, he is a person who delivers and he keeps his promises. So just now, don't ask me if I didn't get that tablet yet. It's in the making and it's going to be here very soon. And we're going to show you some of the things that you can do using it. We don't have any free time sitting on corners and not being engaged because we are going to make everything available to you. Do not forget that you can go on your website, especially my students in Barbuda, because I know you're thinking Miss Weston has given you up. She has not been over for the term. But yes, I am working on a policy that we have these things now, and next term until June, we will be there all the time showing you exactly how, again, you're going to prove to the world that Barbudans can do mathematics. All right? Now, today, we're going to soldier on. We are finished with all of the fractions. We know how to do the additions. We know how to find the LCM. So we're going to take up another mantle, and we're still going to keep with our addition, the operation, and this time we're going to go into the territory of, what do we call it? Look at it, what you see. What do I see that you have here? You're seeing a whole number and a fraction. A whole number and a fraction. A whole number and a fraction. And even if it's two, a whole number and a fraction. And a proper fraction, I must say. Whole number, proper fraction. Whole number, proper fraction. Whole number, proper fraction. What do we call those fractions? Aisha is going to tell me. And they are called mixed fractions, right? So what do we say? Whole number and a proper fraction. You can play a game too, you know. Whole number and a proper fraction. Whole number and a proper fraction. Right, and that is called a mixed number. And that is what my colleague said. Yes, Dr. George said that. Make the children dance in the mathematics classroom. They can dance, all right? They can show Miss Weston some of the dance movements too, because I know they like to go, all right. So get them going. You ever see these little children? Whole number and a proper fraction. Get them dancing in the mathematics classroom. Or let them get a rap with it too. All right, because that is what is coming out. So today, we are going to be dealing with the operation of adding mixed fractions. But I want to take us back to something I did yesterday and then show you how I arrived at an answer. Okay? This was it. I gave you an answer and said that the answer was 9/8. And quite correctly, we said, what did we say, Mr. Cameraman, that was called? Jetta, what did we say? What type of fraction was that? And it is an improper fraction. Why do we call it an improper fraction? Asha, why do we call it an improper fraction? All right, the numerator, and she's mumbling and her children listening. Aisha, why do we call it an improper fraction? Because the numerator is bigger than the denominator. She's saying the right answers, but I am asking her to be clear about giving her answers, all right? Good, she's a star too. Yeah, she doesn't know it, okay? So it's 9/8. But I did not show you because I said after that, instead of leaving it as 9 over 8, an improper fraction, we could have brought it to a mixed fraction. How did we get to that stage? You would have to say, using your denominator, you'd be saying 8 into 9, so we're dividing, it's like 9 divided by 8, okay? And you know you can do this sort of thing, and you're saying 9 into 8 goes once, and our remainder would be 1. But because we're dealing with fractions, we don't leave it in this format. So we just be saying, how many groups of 8 can we get out of 9? And it's 1, and the remainder would be 1 over 8. And that is where that answer came from. Teachers, do not leave the children guessing. Check and see that every step is understood. And after that, when you would have taught it, you know, teachers, check and see. There's some smart children in that classroom who just want to jump over that table and become the teachers. Give them the opportunity to be that. Let them check some of their friends and let them talk and let them understand if the concept you just taught them, that it was learnt by everybody. So I am suggesting to you, teachers, you can talk for 10 minutes, then sit down, watch them go. Give them the other 10 minutes talk, then we come back together, and then they're writing up their little journals. Today, this is what we learned in our classroom. And then you set them comfortable amount for their little homework to reinforce the concept. Do not make it be a drudgery, all right? So that is the aspect in which we want the mathematics education to go down. And again, what did we say? Let them dance in the mathematics classroom. Okay, yes, we have a lot of movements, and that is why I want to congratulate especially King Obstinate. He's my favorite calypsonian. When you hear those calypso, you can't stop dancing, boy. You see your body just going. As soon as it's a da na 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 na, you start right away. All right, well done, Obstinate, and keep up the good works. Yeah, you Short Shirt and Swallow, you're my favorite, and everybody who sings these calypso. I love calypso, my favorite music. Let the children learn them too. All right, so that is where we are. So we have improper fraction, mixed numbers, and now today we are going to show you how we perform the operation with mixed fraction, the operation of addition with mixed fractions. What do I have up here? I have 1, 2, 3 terms. What do I have down here? 1, 2 terms. We are not going to start with a 3-term operation, all right? With this problem, we start with the little ones. So notice that we're talking about a concept, and so we're starting with the little ones. So our first one in terms of adding mixed number, adding mixed fractions. So adding, okay, addition of mixed fractions. So let's go. So our fraction, we're dealing with 7 2/3. So we have 7 2/3, and it is plus 6 3/5. It is plus 6 3/5. Now we are going to learn this properly to see exactly how things are done. All right. Notice what I am doing. Step 1. Add our whole numbers. All right, so you see we have this as a whole number, this as a whole number. So we are going to get those out of the way. So we have 7 plus 6. That is our first operation. So we have 7 plus 6, and that is going to give us 13. Okay, so we're going to write 13 plus, and we can put back our fractions now. So we have 2/3, and it is plus 3/5. All right. So once we would have gotten our whole numbers out of the way, we just have the fractional part to deal with. And it goes along the same method that we have been using for our proper fraction or vulgar fractions. We have to find our LCM, and the two denominators 3 and 5. And what do we have? It's 3, it's 1, it's 5. It's 5 and it is 1 and 1. So the LCM here would have been, our LCM would be equal to 3 times 5, and that is equal to 15. So right away, we know that the LCM is 15. Okay? Now, we're going then to say 3 into 15 goes 5 times. 5 2s would give you 10. And it is plus 5 into 15 goes 3 times. 3 3s would give me 9. And then remember that we have this 13 coming down with us. So it's 13 plus this part of it. So we're getting, it is now equal to 13, and it is plus 19. 10 and 9 would give me 19 over 15. Okay? So I have 13 plus 19 over 15. Now we're not going to leave it like 19 over 15 like that. We are going to break it down into a mixed fraction. I'm going to ask you, look at it, tell me what you think we have to do, and when we come back, because I'm going to send you on a break, when we come back, you're going to tell me, and I'm going to show you how we will proceed once we would have gotten 19 over 15 and we had our 13 plus. So we are at our first step where we would have been adding our whole numbers. This is our second step, LCM and finding the fractions. Second step, okay, LCM, okay, and then after that we would be getting into our addition, okay, addition of fractions, just proceeding how we did along with our vulgar fractions. But we're going to make you take a little break because again we need you to sink in. We may know it, can't go too fast. Mixed fractions, whole number and a proper fraction. Adding them, we add the whole numbers first. That's our step 1. After that, we join them to the fractional part of the operation, find our LCM, proceed as we did with our proper fractions, getting them, adding them, that we're now at this stage where it's 13 plus 19 over 15. We wouldn't leave our answer like that because that is clumsy. So we're going to send you on a break, and when we come back, we're going to show you how we would proceed to give us a simplified, mathematically looking answer. Do take your break at this time.
To succeed in mathematics, you need to build on what you have learned before. New concepts are added to and build upon previous concepts. It is very important that the early material be mastered thoroughly. Similarly, mastery of material from previous classes makes success in later classes more likely. So continually review and practice concepts from previous sessions.
Right, so you had a long break, and I hope that you're with me, because what are we still doing? We are adding. But what is the name of the fraction this time? Mixed fraction. And what did we say mixed fraction was? Yes, a mixed fraction, it has a whole number and a proper fraction. Whole number and a proper fraction. That is why Teacher Pepsi was a good maths teacher for me in infants, because she had us singing a lot of songs. So we did a lot of dancing in that mathematics classroom. Teachers, let your students keep on dancing again too. Last time, what did we tell you? How did we say that you would proceed in terms of adding the mixed fractions? Our step step one, we say, would have to be adding our whole numbers. First step. Step two, we'll be finding our LCM for the fractional parts of it. Okay? And we'd go aside and we'd show them that we know how to find our LCM. And for this one, I'm sure by now you're getting a little trick too that you can see right away. We're multiplying the products of the numbers in the denominator, and the product is giving us our LCM. So we have 15. And then we're going 3 into 15 goes 5 times. 5 times 2, multiplying our answer by denominator to get 10. 5 into, this was 3 into 15, went 5 times. 5 times 2 gave you your 10. And now we're going 5 into 15 goes 3 times. 3 times 3 gave us 9. And what do? Add our numerators and put it over our foundation, which is the denominator. So our answer came out to be 19 over 15 for the fractional part of it. But we're dealing with 13 as our whole number already. And when we look at 19 over 15, we know that that is an improper fraction, because we're saying the numerator is bigger than the denominator. So we again, just as I showed you before, can change that into a mixed number. So we would be saying 15 into 19. And again, if they don't know, they put down their little 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. And then they're counting off their 15. And of course, they would be left with 4. So 15 into 19 would give us 1 and 4 over 15. Now the 1 that we're saying here becomes a whole number too. So if we already have 13 whole number and we get another 1, that would now place us into 14 whole numbers. Can you see that? Because 1 and 4 over 15 really means 1 plus 4 over 15. So up here we can be writing 13 plus 1 plus 4 over 15. And that is why we're going to get for our answer that the answer is equal to 14. The answer is equal to 14 and 4 over 15. Let us take it slowly, because once we learn that, there's nothing else to learn. Here we have our mixed fractions and we have to add them. First of all, we will be adding the whole numbers. So we look for all the whole numbers and we're adding them, and we get that the answer is 13. So it would be 13 plus the fraction from this one plus the fraction from this one. With the fractional part, we're going and looking, treating them exactly like we would have done our proper or vulgar fraction. And we're finding our LCM. And here we know how to find our LCM. And it is 15. We would proceed for our operation. And we would then add the numbers we have in our numerators. And we would have been getting this answer, 13 plus 19 over 15. But we never leave our answers like that. We simplify it mathematically and look and see 13 plus 19 over 15 is an improper fraction. So we transform it into a mixed fraction. And the mixed fraction then tells us that our operation now is saying it is 13 plus 1 plus 4 over 15. When we add our whole numbers, we're going to get 14 and 4 over 15. And that is the answer. All right? So, and again, for our students, our fifth form students, we can say that this operation is closed because we started with mixed fractions and we ended up with mixed fraction. So once we start with a number from a family and we end with the same family member, then we say it is called the law of closure is in operation right here. Teachers, you see how you bring back these things all the time for 5th form and 4th form students, so you don't let them forget and say, oh, I did those things long time in 1st form, I don't remember them. Oh, those was taught in 4th form, I forget these things. Oh, we learned that in 3rd form. Keep it awake all the time, okay? Point out these things to them and they will understand. Right. So what about if we make you try one right now, just before we send you home, to say you will be making one for yourself, proving to me that you know exactly what you're doing. Because next time, we're going to be looking at the operation which involves subtraction. And we're going to just see that subtraction is just the operation that makes the difference, okay? For our subtraction, so that too will be going quick. Teachers, we make certain the first operation that we're teaching, that it is continuous within the others that we have to teach, and just make it reasonably easy for the comprehension from that first stage, because after that, the others are just going to be a legacy from what we taught them initially. All right, so are we ready to try one for ourselves? Right, so what do we have? Another 2 fractions where we have, it's 1 and 3 over 8, and it is plus 3 and 9 over 16. What did we say we were going to do when we are adding mixed fractions? Aisha, what do we have to do? Oh, she's still dumb, yata. Cameraman, can we talk and tell these people what are we doing when we're adding mixed fractions?
First step, add the whole numbers.
First step, add the whole numbers. Aisha, what's the first step we said? Oh, she named Noddy this time now. So we repeat it again so our children can understand. We're dealing with mixed fractions. So the first step, what are we doing, Aisha? Adding the whole number. She's coming to come, so we have to coach her, right? All right. So our whole numbers here. What are the whole numbers here that we're dealing with? 1 and 3. Oh, she named sign person. All right. So it is now. So cameraman, you will have to show them, because if she can't talk, we have to see her, right? We have to see the picture how she's doing her fingers. All right. So it is 1 and 3. Again, look. Okay, come grannies, we're not going fast because we want you to get it. We look, and the first step is adding the whole numbers. And our whole numbers in this case would be 1 and 3. So we have 1 and 3, and that is going to give us 4. So it's 4 plus, and the fractions remaining would be 3 over 8, and it is plus 9 over 16. What is our second step that we must now perform? The second step is the LCM. When you have a student and they're not answering as loudly as you want them to, don't jump down their throat, right? Coach them and let them come on. A little more, and you're hearing her a little better now, so just keep coaching. Just now she'll be shouting and we'll be telling her turn down a bit, all right? So that is it. Okay, so our second step would be to find our LCM, and we know what we're doing here. Okay, so it's 2, and here we're going 2 into 8 would give us 4. 2 into 16 goes 8. 2 again, we get 2. You get 4, you have 2. You get your 1, you get 2, 2, and you have 1, 1. And then we say our LCM would be equal to 2 times 2 times 2 times 2. And we know right away 2 2s are 4. 4 2s are 8, and 8 2s would be 16. And students, are you seeing a pattern here? All right, we have numbers, and you can say that these are multiples of 8. Isn't that true? Yes, so you can say the LCM then, larger of the 2 factors, and it is 16. All right, so try that too. When we find our LCM, what are we in fact doing too? We are expressing the numbers in primary form. as prime numbers, okay? So that is called prime number. And for our fifth formers, another way of writing 2 times 2 times 2, we introduce our indices, and it will be equal to 2 to the 4th. Because what are we saying? 2 to the 1, 2 to the 1, 2 to the 1. And when we have our indices, for multiplication, we just add, okay? That is for our fifth formers. All right, so here we go. And then our third step, then we're getting on with the operation. 18 to 16 goes 2 times. 2 times 3 would give us 6, plus 16 into 16 goes once. 1 times 9 would be 9. And then so we're bringing down the operation all the time. Don't forget to walk with your 4. So the 4 comes down, and it is 4 plus, and it would now be 15 over 16. Aisha, what type of fraction did we get? 15 over 16. It is a proper fraction. And she sounded like harder. Yes, that is how you coach them, teachers. And don't jump on the people you think will never answer all the time, all right? Do a bright one, then do another one, and go for the in-betweens. Mix them up and make certain that they feel, oh, she's not picking on me, or she know I don't know, she's still calling my name. Do not shame them, all right? Encourage them. And don't forget to use your students, all right? Get that first 10 minutes well nailed down. And after that, ask for some little helpers. And then we're going to see how well these people are going to help each other. So right away, the answer here is 4 and 15 over 16. And that is it. Now, I am not going to set a problem for you. I'm going to ask you to try at least 5 of them and to see that you understand what is involved with the operation. If you get into trouble, you have my phone number. Call me and say, I got to this stage and I don't know what to do after this. In the meantime, for my fifth formers, I want you to try this one. Okay, fourth, fourth and fifth formers, I want you to try that one. And little ones, shame them up for me too. You try it and see if you get it right, and see if your big sister got it right too. All right, so we challenge you to do something and see if you can do that. Remember our picture, 5 years old, a little black boy passing his GCSE in England. All right, and it's not a myth. It can be done. Let them play with the numbers, let them see the relationship, and just keep on encouraging them. And do not forget to make them dance in the mathematics classroom, all right, because it can be done. Do enjoy the rest of your evening and the week, and I'll see you again when next time we will be going on to the operation that we're going to be calling subtraction. Nothing too difficult about learning fractions, all right? And teachers in your classroom, as the curriculum development officer has said, there are examples to show you how you can do a practical aspect to all of these. We're just not taking the time to show you. But do not forget to knit up this theoretical aspect with practical aspect of it. So one of the days just said, all right, you're going to be showing me how we're in the real world, we can use these things. What are the practical things and what we can do with fractions in the real world situation. The curriculum development officer has given you some ideas in that text. Please make certain you get the syllabus, because that is what is going to guide you in terms of saying the progress your students or your children will be making in the classroom. It's a division of labor, and do not forget the best teacher for your children are you. Okay, the home, that is where it starts and it comes from. We will facilitate the other aspect of it, but be a joint learner with your students, with your children. So until next time, from us here at the EBU unit and the Ministry of Education, we are going to say good night, do have a good evening, and don't forget to practice, practice, practice. And remember to say a prayer for the family of Sean Williams, because he will always be in our hearts.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.